going to go to the website at www.intrazoid.com, and what we're going to do here is click on APIs. And this will give us a list of all the APIs that are made available by Intrazoid. And for this particular example, we are interested in the Get Company Match Similarity Key API. Now, if I click on this link, it takes me to the actual documentation. It has some technical information, sample code, and so forth. But for this example, we're not going to need any of that, since we're going to be using this within the Intrazoid Cloud Data Connect product. And so all I need to do is register, because once I register with Intrazoid, I'll be giving my API license key, and I will need that to execute the API with the data that we have inside of the Amazon Aurora database. And so once I register, I will have the license key that I need. And the way that the service works is that with every single record in the database, we'll make a single call to the API. And that is why we need the API key. So register, get your key, and then we'll be good to go. Okay, here we are on the AWS listing of cloud services, and we're going to scroll down till we get to database and click on RDS to get things started. Alright, it's coming up. And here you can see we've got a few different options on the left, and it's given us a choice to create an Amazon Aurora database. So we're simply going to click Create Database. And then from here, we've got a few options. We're going to do the standard create, so we can go ahead and make a few choices. We're going to choose Amazon Aurora. We can choose any one of these other databases, and they will work just fine in the same way as the Intrazoid Cloud Data Connect product has native database drivers for each of these. But for this example, we're going to use Amazon Aurora, and we're actually going to use the Amazon Aurora with the Postgres compatibility. Notice a list of some of the different versions that are here. And note one thing real quick, that in order to do serverless, we need to be using version 10.12 at the time of this recording. And so let's choose serverless. And then once we do that, it automatically chooses the version for us. And close that versions window, and you can see here again we have serverless, the Aurora Postgres 10.12, and again we could have provisioned it. It would work exactly the same, but we'll keep things simple and just use serverless. And you can see some of the settings for the cluster identifier. We'll use sample DB. The master username will be Postgres. We'll set our username and password. Connectivity, we'll go ahead and use the default VPC, and then we'll choose the default security group, password authentication for the database options, and then go ahead and click Create Database. Okay, after a few minutes, our database has been created and deployed. And you can see here under DB clusters, it says we have 1 of 40 available. So first, let's go ahead and click on databases so we can see it. Here you can see the sample DB database that we created. And then you can see it's a serverless Aurora Postgres, the region that it happens to be in, how many capacity units, which was the default, and that it's available. So let's go ahead then and click on the query editor. and it's going to ask us which database, which of course is the sample DB cluster, the username that we created, which is Postgres, the password that we entered, and then it's going to ask us the name of the database. Now, the first time that you come in, the general maintenance tables are in a database called Postgres. So that would be where you want to start. And then from there, tab out of that and connect to database. Okay, then it brings us to the query editor screen, and it does pre-populate this with a query for some of these information schema tables that we could run. But for now, let's go ahead and delete that. And we're going to create a database for us to use for this example. We'll simply use the SQL statement, create database, and let's call it Interzoid. And I will run that. Okay, and after we create that new database, we need to connect to it. So let's click Change Database. And it's going to ask me again which cluster, same one. Again, my Postgres username. And I want to enter the name of the password, of the database that we've just created. Tab out of it, hit Connect to Database. And now we are here. And now at this point, we're back in our editor. And here is where I can begin to start entering some SQL statements such as create table, etc. ... But instead, we're going to make it easy, and I've pre-prepared some create table and insert statements to create our demonstration database. And so if you just go to the link on the Interzoid website, we can just copy and cut that data, copy and paste it right in here to our editor. So here we are on the Interzoid website on the sample test data page. And now I could download the raw data from this company names link here for our example, since company names is what we're going to be matching on. But then I would have to create the table and load it into the database with a load statement. So instead, we're going to actually go to where the SQL is, and I will click on the company names SQL link, and it will bring up the actual SQL statements that we need to create the table and then insert the individual records so we can get started with our matching right away. So I will simply highlight the text here, grab all that data, and just do a Control-C and copy. We'll come back to the query editor here within our Aurora serverless database and simply paste in those SQL statements. So I can go to the top here and you can see the create table statement, the two fields we're going to create, and then all of the records that we're going to insert into the database. Simply scroll down and I am going to run that statement or that set of statements by clicking run. And then as it's running, you can see it's doing the statements individually, and here they are pending. Now, after hitting the clear button, we can test that our table was created properly simply by typing select star from companies. Coming down, clicking run. And our query will run below, and we can see the column names and the data that we're going to be using for the rest of this demo. So here we are at the website landing page for the Interzoid Cloud Data Connect product. And so we'll just scroll down until we get to the place where we can actually download the product, and we'll click on that. And here we are on the download page where we can actually download the product. So we'll scroll down and you can see that there's versions available for Windows, Linux, Darwin for the Apple Mac, and Solaris. Now, since we're using the Aurora serverless database within AWS, it's going to be easier if we stay within our virtual private cloud. So let's just go ahead and download the Linux version. And by the way, we're going to use the non-ODBC version. You can download a version with ODBC, which is something you might want to do if you're connecting to an Oracle database, the IBM cloud, or SaaS application like Salesforce.com, something where an ODBC driver would be required to connect. But in this case, since we're using Linux, if you were to do that, you would then have to install ODBC on Linux first. Well, we don't need that because, again, since we're using Aurora, there is a native driver for Postgres built right into the Interzoid Cloud Data Connect product. And so we're just going to go ahead and download the Linux non-ODBC version for our purposes here. Here we are at the Linux command prompt on an EC2 instance within AWS. You need to have Interzoid Cloud Data Connect installed, which is of course a quick and easy install. And again, it's important that this EC2 instance is in the same virtual private cloud known as a VPC within AWS, and also a part of the security group that can access your Aurora serverless cluster. In order for this to work, the default security group will suffice for that. Now, we're going to execute commands using Interzoid Cloud Data Connect from the command line with some parameters set, including a connection string. Here, we're using Linux to access the Aurora Cloud Database on AWS for simplicity, but it would work the same if we were at a Windows or a Darwin command line prompt and accessing other data sources as well. So here we are at the command prompt, and we're going to execute our command to access the Aurora Cloud Database. So I'm simply going to paste it in, and you can see here the function that we're going to use, and we're going to be generating a match report here so we can use some fuzzy matching capabilities available from the API to generate a fuzzy match report and identify that inconsistent data. This might be a place where you could stop the video if you want to take a look at the parameters a little bit more closely. And again, this would work the same if this is in Windows, Darwin, or what have you. You've got the function name as a parameter, company match. This tells us which API to access on the Interzoid Cloud API platform. Target is the driver that we're going to use, so we're going to use a Postgres driver, which is how we set up our Aurora Cloud Database. Here is our license parameter, so this is our API key that you obtain from Interzoid when you register at our website. And then here DSN is our connection string, and this is the endpoint provided along with user ID and password when we're at the AWS Aurora website. Endpoint is some information that they'll give you as part of your database cluster, so you need to obtain that. Here, algo is the algorithm we're going to use as part of the company matching API. There's some different options there. Wide is the broadest possible match. Then table, this is our table name, which is companies if you remember. And then the column we're going to use to perform the actual algorithmic matching, the generation of those similarity keys that will help us identify matching company names. That's the column parameter. So we're all set up to run the match report. Okay, click enter to execute. And it's going to connect to the database across the cloud, to the Aurora Cloud Database, is going to process those records within the table that we created. And for each one, it's going to actually call the API, generate the similarity key, and then at the end, cluster those records that share the same similarity key. So we're actually matching based on the similarity key that we've appended to each record here, rather than the actual company name data itself. And that's how we overcome the inconsistency. So you can see here, Apple, for example, there's several different variations of Apple, and they all share the same similarity key that was algorithmically generated using knowledge bases and all sorts of different types of logic, including some machine learning, different versions of Ford, Arctic Flooring, Hilton Resorts, JP Morgan Chase. And again, we just dump the file to the screen. This could be saved to an external file. It could be emailed. There's all sorts of different possible things. An orphan non-matching file could be created. There's a lot of different things that we can do when we're creating this match report as part of this process. And again, this is just a report. We've got some additional processing that we're going to do here as part of the demo next. Now that was the match report that gives us some insight into the company name redundancy challenge we have that is likely affecting all of our reporting and analytics. Now, however, we are actually going to insert similarity keys into a new table, along with the company names, all automated of course, that will really open things up to us and expand the ability to solve some of these challenges. Now again, I'm going to paste the command in, and you will see that there are some additional parameters here in the command line execution string above and beyond what we did for the match report, including after the column name that we're going to be matching on, we're going to be setting keys only equal to true. Gen SQL is going to be equal to true, and that will indicate to Interzoid Cloud Data Connect that we're going to be generating similarity keys that we want to see for every single record in the database. Create table equals true. That indicates that we're actually going to create a new table and insert these keys into that table. And of course, while there is a default name, we're going to set a new table name so we have control over what this table will be called so we can put it to use. Now we're going to click enter and run. And you can see that the connection is successful. The table is being created and we're processing the records, and we've finished. So now we can go to our database and actually take a look at the results. Okay, here we are at the query editor for the Amazon Aurora Cloud Database. And now we want to check to make sure that all of our similarity keys were inserted into our new table properly. So to do that, I can just run a simple query, a select star from company sim keys, which was what we indicated with our new table name when we issued our command from the command line. And I'm going to scroll down and I'm going to run that. And then while that runs, I should get returned here the company name along with the associated similarity key. So we can see some examples here. Costco stores and Costco generated the same similarity key. Those two just happen to be next to each other. Same with Red Lion Enterprises, the Red Lion, and so forth. So we can click on through if we want to see the results. But now that we have similarity keys that exist for each company name record in the table, we can use that data to run multiple match reports based on different matching criteria. We can join records across multiple tables using these similarity keys as the basis of our matching rather than the actual company name data. And that will give us much higher match rates across data sources and data tables, and of course a much higher level of success. We can also use these similarity keys to prevent new redundant data from entering our data sets by simply generating similarity keys for all new data and comparing it to existing data. the sky's the limit at this point, and that's the value of getting the similarity keys directly into the Amazon Aurora Cloud database. All automated with a single command, as now we can do anything we want with them. And that's it. You've got your similarity keys there. You can run this over and over, and once the similarity keys are in place, you can do anything you can think of.
Thank you.